Good afternoon, ladies and gentlemen. Welcome to the international webinar on unveiling the synergy of architecture and artificial intelligence, organized by ISERD in association with IRAJ Webinars. On the behalf of entire organizing committee, I'm Isaac Behra, organizing secretary, would like to welcome you all for this webinar. Apart from organizing various seminars, expert talks, and conferences, we have various highly rated multidisciplinary journals in the field of science, engineering, technology, and management. Since our inception, we have been arranged various international conferences at various parts of the world like New York, London, Australia, Hong Kong, Dubai, Bangkok, Kuala Lumpur, India, etc. More than 2 lakh people across the globe are associated with us. And more than 5 lakh research papers have been presented and published during our journey. Today, I'm glad to welcome you all as a member of this fastest growing network for the advancement of science and technology in terms of research and innovation. Today, we were very much fortunate to have an eminent professor and expert who is joining this webinar as an expert speaker and guest. Her name is Dr. Maha Fauzi Anbar. Presently, she is working as an associate professor, the Higher Institute of Engineering, Shore Academy, Cairo, Egypt. And also she's working as executive director at Beyond Engineering and Consultation. Now I'd like to welcome our Professor Dr. Maha Fauzi Anbar to deliver the webinar.
Okay, thank you so much. Good afternoon, everyone. I'm Maha Fauzi Anbar, Associate Professor of Architecture. It's a great pleasure to give this lecture. Today, we embark on a transformative journey through the dynamic intersection of architecture and artificial intelligence. Our exploration of the latest trends promises to unravel the future of architectural design. Today's topic is unveiling the synergy of architecture and artificial intelligence. This lecture delves into the symbiotic relationship between architecture and artificial intelligence, presenting a comprehensive exploration of the latest trends reshaping the design field. The lecture concludes by envisioning the future landscape where architects embrace AI as a creative partner, propelling the industry towards unparalleled heights of innovation, sustainability, and efficiency. Artificial intelligence refers to machines mimicking human cognitive functions such as learning and problem solving. It involves computer systems executing tasks that typically require human intelligence, like speech recognition or decision making, for example. Speaking about machine learning, let's first talk about what learning is. In the first place, learning is the acquisition of knowledge or skills through study, experience, or being taught. We have 2 types of learning. We have machine learning and we have the normal human learning. The model of human learning categorizes learning styles into 4 main segments that are visual, auditory, reading and writing, and kinesthetic. These represent preferences for processing information through visual cues, auditory stimuli, written text, or hands-on experiences, according to each type of person. Also, the additional categories, analytical learners, social linguistic learners, nature learners, and solitary learners extend the understanding of individual learning preferences beyond the basic 4 types. Logical and analytical learners favor reasoning and problem solving. Social and linguistic learners thrive in group interactions. Nature learners connect well with the environment, and solitary learners excel in that kind of independent study. These categories provide a very significant perspective on diverse learning styles of, as we said, the human learning. That was the human learning. On the other hand, machine learning is the field of computer science that is focused on developing systems that can learn and adapt autonomously. Utilizing algorithms and statistical models, machines analyze data patterns, draw inferences, and improve performance without explicit programming instructions. As we said, machine learning enables machines to learn through algorithms. These algorithms analyze real data to generate a model enabling predictions about the class or type of new data. This is how machine learning actually works. In machine learning, we have two types. We have supervised and unsupervised learning. The supervised learning requires labeled data where each example is tagged with its correct class. On the other hand, the unsupervised learning lacks labeled data. The algorithm itself categorizes based on inherent characteristics. Both help identify patterns and classify new data. We have machine learning and we have human learning, and we have some similarities and some differences between them. Human learning and machine learning incorporate similar processes and data processing methods such as prediction and memory. But there's one core thing that distinguishes human learning from machine learning. That's the use of emotions. Our learning process are not always very pragmatic or output oriented. I mean here, the human learning system. Emotions distinguish human from machine learning. Machine learning enriched by emotions benefits motivation and understanding, but emotional biases may hinder it. Machine learning lacks emotional intelligence, ensuring the objectivity, but limiting the understanding. The optimum is balancing emotional richness and computational objectivity, which is crucial for a comprehensive approach to learning. And as we see in this graph, we have memory in both of them. Of course, we can talk about the capacity of the memory in both systems, in machine learning and human learning, and in which type it's going to be really for big capacity. Artificial intelligence in architecture, as it's the topic of today's lecture, not just the artificial intelligence, revolutionizes the industry in so many ways, driving innovation through generative design, where algorithms explore myriad possibilities to create optimized structures, design optimization facilitated by AI, streamlines processes, ensuring efficiency and sustainability, building performance monitoring, employs AI to collect and analyze data, enhancing energy efficiency and occupant comfort. Parametric modeling and computational design leverage AI algorithms to create dynamic and responsive design. The integration of smart buildings with the Internet of Things enhances real-time adaptability of the whole features and the real-time data of the building. AI transforms architecture by augmenting human creativity, improving efficiency, and fostering sustainable, technologically advanced built environments. Generative design architecture employs AI algorithms to explore and generate diverse design possibilities based on specified parameters. This innovative approach enables architects to rapidly iterate and discover optimized solutions, fostering creativity and efficiency in the design process while pushing the boundaries of architectural innovations. Generative design and architecture offers simultaneous exploration of numerous design options, often hundreds of thousands, enabling a more comprehensive creating process. As we said previously, we were speaking about the memory of the human learning and the machine learning. Now we have like exploring so many alternatives. Of course, this is going to be a leap in using AI. This facilitates mass customization through Industry 4.0 techniques like additive manufacturing, making it easier to experiment with new designs and modify specifications efficiently. The process also accelerates design timelines by automating repetitive tasks, providing engineers with multiple design options to choose from. This process was usually done by architects, and they were experimenting a very large number of alternatives. But now using AI, they will have endless number of prompts, and they can just explore and analyze and choose from them. With a shallow learning curve, generative design empowers entry-level designers to create functional and innovative solutions from the outset, enhancing accessibility and efficiency in the design field. In this slide, we can see how generative design created these forms based on some inputs instantly. It's essential to enhance the design process as it is. Between every primary idea and final result lies a long rough path with a lot of dead ends and roundabouts. Of course, this is the experience of architects in designing everything. It's a to and fro process of trials and errors until you arrive at an equilibrium of many different requirements that you need to meet. That is the bulk of what an architect does. This is a complex process as every change can influence countless other elements, compromising previously established decisions. The architectural design process is making an enormous amount of decisions, making the traditional way of modeling very labor-intensive and time-consuming. And this is one of the points of power of using AI in architecture. In the pre-generative design stage, now we have the three phases. In the pre-generative design stage, architects establish project goals, identify key parameters, and set constraints. And this is going to be the most important part the architect will play. It's setting the goals and parameters and constraints, as this is going to be the key process he is going to put as an input in the AI-generated platform or tool he's going to be using. Data such as regulations, commercial requirements, and performance criteria are input to initiate the generative design process. And that's why it should be very accurately done. The main generative design stage employs computer algorithms and a cycle of generation, evaluation, and evolution. The algorithm creates diverse designs, evaluates their compatibility with predefined requirements, and evolves based on the most suitable options. And the last stage is the post-generative design stage, allows stakeholders to explore and choose from the final set of designs, with architects refining the chosen option to meet constraints and requirements. And now we just can't neglect the role of the architect in setting the goals. And at the end, of course, there will be a contribution in refining the output to the required data. For example, to generate this idea, a myriad number of alternatives was explored with a huge number of iterations to explore them and get the final product that will be fabricated. Generative design is like having a smart helper for designing things. You tell it what you want, but instead of designing one thing at a time, it quickly makes lots of options using special rules. Of course, you set the rules as input. It's like exploring many ideas at once, and sometimes it even finds cool and unexpected solutions that might be hard to think of using regular methods. It's like having a creative assistant making the design process faster and more inventive. As we see here in the video, Sidewalk Labs LLC is an urban planning and infrastructure subsidiary of Google. Okay, wait a second to play. Okay, the video again. Its stated goal is to improve urban infrastructure through technological solutions and tackle issues such as the cost of living, efficient transportation, and energy usage. It unveiled a generative design tool using machine learning for urban planning, using data like geography, regulations, and weather. The tool generates potential scenarios for architects to refine with machine learning to improve over time, enhancing its ability to produce better projects based on accumulated experience, as we can see in the video here. It instantly generated a number of alternatives which saved time and effort and enhanced the efficiency of the output. And that was all based on the input of the architect concerning the geography, regulation, weather, and whatever the constraints we have in such a project. So this is a generative design tool. Also, generative design can be based on various inputs, including parameters set by humans, data from the environment, or existing design constraints. As we can see here in the example, we have text-to-image generative model method. Here, it takes data from, such as the text, okay, this is text-to-image. It encodes the data based on a large language model, and then after the processing, the encoding, it decodes the image to get the result of the required image. So this is how more or less the generative models work. We have a lot of we spoke about the text to text. Let's speak now about text to text. For example, in text to text, using a tool like ChatGPT, maybe it's the most famous AI tool now. A form of generative AI, architects can create general building specifications, optimize BIM data descriptions, improve technical documentations, and produce project reports. And it can help the engineer with a lot of tasks. Let's have a trial of a prompt actually using ChatGPT. In this prompt, a detailed report was requested, as we can see here. The output included data about planning and design, site preparation, structural framework, okay, in this prompt using ChatGPT. The phases that are still under construction with their timeline, and the risk assessment, which includes weather delays, safety, and other risk assessment factors. The report was produced with very slight details about the project as input. Of course, the more input and data you have, the more accurate reports that will be produced. And the prompt can even be refined to get more accurate output according to the input you have, or you can just get the outlines and format of the report, and you can input the data manually afterwards. Okay, let's now go to the text-to-image tools. Maybe they are the most preferred by architects. For example, in this prompt, using Midjourney, an interior space was visualized and produced using a text prompt. This prompt specified the style and the surroundings to get the output image as required. This prompt is using Midjourney. As we can see, it produced a very good interior visualization of a room. Text to image also works for random photo descriptions, as you provide your detailed prompt not only for buildings, but for objects, cars, sceneries, and a lot of other things. And here, speaking about cars and automotives, AI is not just about conceptualizing car designs, but for some car brands like Tesla, as we can see, we have Tesla's autopilot and full self-driving. Tesla, that is led by Elon Musk, as we know, has been at the forefront of incorporating AI into its vehicles. The autopilot features that include adaptive cruise control and lane keeping assistance. It utilizes artificial intelligence and machine learning algorithms. The company is also actively developing full self-driving capabilities, that the autonomous vehicle. So AI will not just work for conceptualizing the car designs, but now actually it's used in the process of enhancing the user experience of cars. It's also useful for interior designers to create mood boards for their clients after getting brief and requirements from the client. The generated mood boards will be the start of the project, as the prompt will provide details about the style and color palette. This is going to be very useful for interior designers, as the first step, we just get the client brief and their insights and what they really need in their project and in their design. So having a prompt for the mood board and here in the prompt, we can see that we set the type of the space. It's a restaurant, the style, it's boohoo style design, and the color palette, okay? So now we can get a lot of mood boards for clients, and even maybe before meeting the client, we can go to the first meeting with just a large number of mood boards. It's gonna facilitate the process between the architect, interior designer, and their clients. In this prompt, as you can see, the prompt is so much detailed. It's not just a line. A detailed description of the required building was provided, starting from the number of floors, the outdoor space features, as we are having a pool, we are having green space. It also included the location of the building to get a visualization of a building that suits the context and surroundings. Here we determined the villa location to Dubai, and that had some reflection on the design. It can create concept for projects to help designers with the inspiration of the design project, as we know that the concept of the project might be one of the hardest things. Of course, the artificial intelligence and AI tools will not just put the concept or create concepts, but it's gonna help us with the inspirational process at the start of each project. In this prompt, the architecture design style was determined, as well as the sky cover and light. So you can adjust the whole environment. Here, the building is from the Victorian age and rustic colors and dusk light. So you can just, of course, you can choose the building style and the surrounding context as well. Let's jump to another tool and platform, which is the Promi AI. Here we can see the prompt for creating a wide view of a whole building. It's a cultural center in this prompt. It shows a vast landscape area. It can aid the architect in visualizing and conceptualizing the project, not just the architecture design of the building, but also the surrounding and maybe the landscape. You can get some inspiration for the landscape design you are about to design. Another prompt also by Promi AI. The prompt can also determine the presentation style in order to fit the required submission style. Here we wanted a watercolor of the building. Okay, of course we can have a realistic rendering, but in this case, you can adjust the presentation style you need according to what you are submitting this project for. The prompt here can visualize something like prediction of a futuristic design, which helps designers in creating more creative and innovation design ideas. In this case, it was a futuristic aquarium design. One of the remarkable things AI generative tools can do is create photos that look sketchy and realistic, as well as to serve the required submission constraints you are applying to. AI tools also enable the user to render sketches and choose the render style as well. So from a very basic sketch to a rendered photo, of course, a more mature sketch would have produced a more mature render. A pencil drawn sketch like this one, it can be transformed into renders of buildings. You can sketch a simple idea in seconds, and as you're sitting and just scan it, and AI tools will render it for you, and you will choose the render style of it. As we can see here at the top of the we can see the interface of the Promi AI. So you will choose how would you like your render to look like. Another point is that is very attractive for architects is that AI enables the user to choose an image as the inspiration and ask the AI tool to create similar design or designs that are inspired by this by the chosen image. So if you like a certain architect or designer, you can put one of his works as an inspiration, and then the AI can create to you like designs that are inspired. So you can get the inspiration and then, like maybe the first step of your project will be done. You can also make photos into sketches. This is the opposite process. It enhances the artistic expression of photos, experimentation and exploration. Maybe at some points you just need a hand-drawn sketch. So you might start with a text to image prompt, and then you produce an image, and then you can transform your photo into a hand-drawn sketch. So this is really impressive for architects, I guess. And the last thing is that the same prompt in different styles can result. We can have two different outputs. We can see here, one is photography general and the other is realistic fantasy. So we have the same prompt, the same text to image prompt, and they generated totally different things, and maybe I prefer one or another according to what I really need. So that was all for today. As the journey of AI in design draws to a close, let's unveil some insights and inquiries. I guess maybe a lot of us will have some questions like, what if our structures could not only embody beauty, but also intelligence? This is going to make a very big difference, I guess, from my own point of view. The synergy of human creativity and artificial intelligence in architecture opens doors to a future where buildings just adapt and learn and evolve. What kind of spaces could we create after this? How might our cities thrive, not only on the scale of buildings or the scale of architecture, maybe the scale of urban design, the scale of city planning. At the end, thank you all. And I would like to thank ISERD for allowing me to give that lecture today. Thanks for your presence. Your attendance is really appreciated. Thank you so much.
Thank you, Professor, for sharing your valuable time and for joining this webinar. On the behalf of the organizing committee, ISERD conference and IRAJ webinars, I would like to thank all our sponsors and coordinators. I would also like to thank our president. We're happy to hear your comments and compliments, suggestion, or at our Facebook and Twitter page. This video will be available shortly in our YouTube channel. Kindly subscribe our official YouTube channel, IRAJ conferences and seminars, for all past and upcoming webinars and expert lectures. Thank you all. See you on another webinar soon.